In 2017, the Very Large Array Radio Telescope, located in the plains of New Mexico, detected radio bursts in a star-forming galaxy that lies 500 million light-years away from us. The bursts happened in a binary star system where one of the stars had once turned into a black hole. It sank to the star's outer layers, which made it emit a tremendous amount of gas and dust. And when the black hole swallowed up the star's core, gravitational forces triggered energy flow in the star's layers, and that's precisely what we saw on Earth. That was how a dying star warned us of a terrible danger: space cannibalism. These events took place far away from Earth, but is it a rare occasion in outer space? Who might be the one to attack us? And is it possible to get away from space cannibals? So, why is it a bad idea to come close to black holes? Black holes grow by feeding on material and gain weight of millions or sometimes even billions of suns. And the bigger they become, the stronger gets their gravitational force, which can pull large objects. Stars are heavy, and that makes them easy targets. But perhaps some small space probe could sneak past a black hole unnoticed. Just for clarity, imagine that the space probe is a speck of dust lying next to a vacuum cleaner, or next to a whirlwind, or more specifically, a speck of dust next to a black hole. The thing is, the gravitational pull of a black hole is so strong that there's absolutely nothing here on Earth to compare it with. It doesn't matter how small the probe is, it won't be able to escape. However, it's not so easy to spot a black hole eating anything. Tomoharu Oka, an astrophysicist at Keio University in Yokohama, Japan, together with his colleagues, discovered a turbulent cloud at the Nobayama Radio Observatory. The cloud lies in the core of the Milky Way, approximately 25,000 light-years away from our planet in the constellation of Sagittarius. But some previously unknown massive object stirred up interstellar dust with its gravity, and presumably absorbed some portion of that dust. Searching for causes of turbulence on old X-ray and infrared pictures revealed nothing. Given the tiny but massive size of the alleged offender, researchers suspected that there's a black hole located close to the cloud, and its gravity is what stirs the gas. Invisible but lethally dangerous, it will grip all the small things that will happen within reach and gobble them like a space garbage truck. But what about a thing that equals its size? If there's no way for small objects to hide, can there be a thing able to avoid such a miserable fate and having a mass comparable to that of a black hole? A neutron star is a compressed remnant of a massive star, and it's just a bit lighter than a black hole. A worthy opponent. Recently, scientists have been watching their interaction that took place more than 900 million light-years away. And since both of them are hard to detect in visible light, that was the first time ever when an interaction of this sort was captured. That was made possible only thanks to advanced gravitational wave detectors. The collaboration of LIGO, Virgo, and Kagra detectors has reported on a black hole that devoured a neutron star without emitting even a single flash of light. That produced gravitational waves, which stretch and contract the fabric of space-time, and gave us a chance to become the first humans to see a grand spectacle of space cannibalism. And most surprisingly, in just another 10 days, the detectors caught another similar merger. This means that such epic encounters happen regularly and all over the cosmos. Based on the rate of detection, scientists have calculated that they occur approximately once a month and within 1 billion light-years from Earth. Black holes don't bother about sizes. If they approached you, get ready to be swallowed up. It looks like eating their next of kin is some everyday thing for black holes. And what about other celestial bodies? What else is known as a space cannibal? The first time humanity witnessed space cannibalism happened long ago in the 17th century. This is C.K. Vulpeculi, the oldest reliably documented nova. Novas are bright flashes like supernovas, but somewhat smaller. In 1970, several European astronomers discovered a new star in the sky. It was clearly visible, even to the naked eye, and was located close to the border of the constellation of Cygnus. Its brightness repeatedly changed for 2 years until the star vanished from sight. In the 80s, a team of astronomers found a very faint nebula around what could possibly be a remnant of the star. They examined the chemical composition of the gas and concluded that the star hadn't exploded, but had instead collided with another star. If this happens, a star explodes while swallowing up its opponent and ejects the substance hidden in its stellar core into space. But space cannibalism doesn't end here. Objects that avoided or survived colliding with other objects form galaxies and live by the same rules. All around the universe, cannibal galaxies collide and gobble up each other. We know that because Andromeda, our close neighbor, belongs to that club. A vast concentration of mass at its center results from a previous collision between two supermassive black holes that lie at the center of galaxies. But there's more to come. The force that emerges when one galaxy eats another can distort or pull orbits of stars to their centers. This means that when it was having another galaxy for dinner, Andromeda let the black hole in its center devour more stars and do it even faster and more effectively. But if space cannibalism is so common that we can even call it a daily space routine, how will it affect our universe? Just imagine, black holes will be absorbing dust, planets, and stars, and then they'll start eating each other. Even galaxies will be devoured by black holes located in their centers. As a result, their materials will be neatly stowed in black holes that will gradually merge into one final black hole, the champion. Scientists call this scenario for the ultimate fate of our universe the Big Crunch, and it's supposed to result in a Big Crunch singularity. It's not yet known if that's really how our universe is going to collapse, since we're still in the process of space exploration. But looking through those tiny telescopes with our tiny eyes and seeing all the horrors of space cannibalism, you don't have to be a genius to realize that there's probably going to be a sad ending. And you know what? I'm not okay with this prospect. We've got to do something. Here's my plan. If black holes are after the matter and want to store it in one place, we need to do the opposite thing. Listen up, everybody. Stop keeping your stuff in order. Stop it right now. Make a mess. Dump your clothes everywhere you see. Try your best to stop those black holes from reaching them. And in case someone criticizes you or asks why your room is such a disaster, explain that you're saving the universe. Or show this video and make them share the responsibility.